For this example, we're asked to solve for the centroid location for the composite of this box beam. This box beam consists of a rectangle measuring 10 by 16 wide centimeters, and it has a hole in the center, and this hole measures a distance of 12 at the base and a height of 5. So to determine the location of the centroid of the composite structure, which would be Y bar for the composite structure, we first need to break this up into parts. So we're going to start with the overall rectangle itself, and then the second part will be the hole. So we then will calculate the area of this part for each one. And of course, the hole will have a negative area. I then have to determine the centroid location based on that datum, that zero line, for each one of these parts. Next, we have to then multiply the area times the centroid location for the individual parts. To determine Y bar, we're going to use the equation, the summation of the product of area times the individual Y bar location divided by the area. And this results in a Y bar for the composite structure of 4.7 centimeters. All right, now that we have this information, we can determine what the moment of inertia about that x-axis is. Remember, we're about the x-axis, so we're interested in the Y bar for these individual parts. That would be the D. Okay. And what we have to do then is to calculate the D for each one of these parts. And that's going to be the difference between the individual centroid location minus the location of the centroid for the composite shape. So that's the distance between the individual part's centroid and the composite. So then we've calculated D for each individual part. And again, it doesn't matter if it's positive or negative, because the next column over, we're going to take the square of that. Okay, so then we're going to A, the area, which we already found out, times D squared. All right. And then the next column over, we're going to find the moment of inertia for the part, regardless of its location in the composite structure. And that formula we're going to use is, for a rectangle, is 1/12 the base times the height times to the third. Okay, and this results in 1,333 for the rectangle, and for the hole, again, it's going to be negative because remember, it's to the third, so it's going to be negative. Then we're going to determine the moment of inertia around that x-axis for the composite, and that's going to be the I for the individual part plus AD squared. And that results in 1,184.33 centimeters cubed. And we're going to then report that to 3 significant digits, and we're left with 1,180 centimeters cubed.